So, and that's why we created this widget. You might think of it as a tool that adds a new visual capability to Niagara, making it easier to see and interact with the building data. There are many advantages of having 3D elements in a BMS. It's easier to find the location of equipment. It simplifies personal onboarding, and it allows you for better understanding of how complex mechanical systems are interconnected. It also makes your BMS look cool and different. So some main features of these widgets are, so it allows a 3D model to be rendered in a browser, in a web browser, using WebGL standard. And it's also allow the computer to utilize your graphical acceleration card to do that. The widget uses GLTF or GLB file formats. This is established, well-known file formats for 3D models, and they are optimized for transfer for the delivery of the model, so they're reasonably small, and also that allow apps and the software to process these models quite quickly. In our widget, we have a few properties, few options for the integrators to customize this model after it's embedded into Niagara. So the integrator can customize some camera settings, some lights, and some controls. The end user, after the 3D model is shown to them, can pane, rotate, and zoom this model. And also integrator can add annotations, which is basically a hotspot and a pop-ups. And I will display it later. So let me share my Niagara and I will demonstrate how it works. So hopefully you can see it now, and I will just build this 3D model, not the 3D model, I will build the widget right here in Niagara. So I already have inserted in the station a few 3D models. So as I say, they consist of the one or few files in GLTF or GLB format. I will just save the ORT of one of these files. And now all I need to do is just to drag and drop this widget from the palette into the PX file. It's empty now, so all I need to do is just to supply the ORT of the 3D model file. And that's it. So we have embedded 3D model into Niagara. Now I can rotate it using my mouse. I can zoom in and out, and I can also pane it. So an end user can do all of that in Workbench or in a browser. It will work identically. There is a small window here. This window is usually not for the end users. You could hide it, but it's quite useful for integrators. And there are few bits of information that's useful for integrators. So first is a position. So it's the position of the camera, and camera is basically our view. So from which point we are looking at the model. And if I go around, as you could see, the position, it's X, Y, and Z coordinates. It changes, or we could change it here separately, each of them. The next one is a target, is a point where the camera is looking at. Then you have a background, it's just a color outside. Auto rotate is just a nice option that you could switch on, and it will just rotate the model. And the very last one, also quite useful, it's a coordinate where I click right now. And I will see how we could use that later. now I will demonstrate some of the properties of the widget that we have. So the widget, when it downloads, when it renders the 3D model, it tries to determine the position of the camera automatically to see the whole model the best way. And quite often it does it successfully, but quite often, for example, in this case, well, not the whole building is visible, and the integrator might want it to be to look differently when end user will open it. So what I will do right now, I will find the best position that I would like to have, and then I will just make a screenshot of this control part. And then I will set it in the properties. One more thing is that I don't really like the background in this particular case, so I will just try to choose a different one. This one is better. And I will save this code of this color that I found. Good. Now we're going into the properties. And there are quite a few properties, so we are not showing them all by default. You need to add them if you want to change them. You don't have to. The only mandatory property is this model one. Everything else is not mandatory. So I will add the background, and I will paste the background that we just created. One more thing, I will add some camera controls. And here I need a position, which is the position of the camera, and the target. So where the camera should look at. So the position should be like that. I just copy it right now from this window that I took the screenshot before. Okay, let's take a look how it looks. Okay, now it's better. One more thing that I would like to demonstrate is this annotations. So this is our solution, how we can basically connect the model, because right now it's just a nice 3D object that the user can look at, but it's not connected to the Niagara data. And the way how we think of that is that we could allow annotations. Annotation consists of the hotspot. It's a point where the user can click, and when the user click on it, two things could happen. First, we could move the camera to some preset position, and the second thing is we can open some extra information for example, piece of equipment that we click on. So let's assume that we have in somewhere here, well, something like a pump, for example, for the pool. So I click on this point, and now I have the coordinates of this point, which I also make a screenshot of. And one more thing I want to show. So I have created previously a very small PX file like that. It's you could put absolutely everything on this PX file. And this, in my case, it's, for example, file that have some historical values for temperature, whatever. And I will just copy the ORT of this file. So now back in our model, I will add annotation, and I will add one child. There could be multiple annotations, of course. In this case, I will just create one. And for this particular case, I need position. So the position is the position of this pop-up. Sorry, not a pop-up, hotspot. Then I need a camera. It's a position of the camera. And then I will need a pop-up ORT. Good. So pop-up ORT will be the one that I just copied. position of the hotspot will be the one that I copy from that window. And the same for the position of the camera. And let's take a look what we have. So that is it. And how it works. If you click on it, the camera automatically moves somewhere. And the PX file opens here. So we could put this hotspot on the equipment, on the buildings, on the floors, and have some extra information here. Of course, this one can be a hyperlink, so we could click on it and open some completely different, classical Niagara view. There are different ways how 3D models can be created. This particular model was created by the 3D designer. It was fully modeled in a software like Blender or 3D Max. But there are different approaches to do that. There are other approaches to do that. And one of them is called photogrammetry. And photogrammetry is when you have a drone, and drone just fly around some building and just make a lot of photographs. And then these photographs are fed into a special software, and the software creates so-called point cloud. And then out of the point cloud, it creates a mesh of surfaces, 3D objects, and then it applies textures on these 3D objects. And that's example of that. So the result could be quite good, especially if viewed from the distance. The photogrammetry can be a very cost-effective solution for large campuses, for example. Well, even more than the campuses. This is basically a part of the town, of the city. Imagine that you have a BMS in some of these buildings, and again, you could have a hotspot, clicking on that and just see real-time information about this particular building, or you could click and go inside of the building BMS and look what's going on there. Another approach for things like campuses could be that you don't have to create photorealistic 3D model. This one is like a cartoonish one. And the advantage is that it's very small because there is no kind of heavy textures or anything. And it's very quick to load. But still, you can navigate it. You could go around and you could put some equipment which you could monitor by clicking on that. Not only exteriors can be shown. Classical floor plans, like this one, also can be in 3D. So this is some sort of office. They could be shown as a separate model or as a part of one building model of the big building where you looked at it from exterior and then go inside. So imagine you can allow your client to literally go inside of its own building and walk around, come to the equipment and click on this equipment to see some real-time information. One example for that could be data centers. They are being built pretty much everywhere these days, and there is a lot of equipment inside of them. Generators, UPSs, server racks. And now the user can come to its own UPS virtually, click on it, and see real-time information and historical information, of course, of what's going on right now with this particular UPS. So it's quite a visual way for you to show for the user to control their system. And talking about equipment, of course, some other complex equipment can be modeled, something like that. It's a pump skid. So for mechanical people, it might be much more visual to see this in real 3D compared to the two-dimensional PID diagram. You could click on these pumps if you have a hotspot and see information about them. That's another approach. So that's it about my 3D widget presentation. If you have any questions, please put them in the Q&A window, in the Q&A button, and we will try to answer them at the end of this session. And yes, we believe that this widget is pretty unique. We are not aware that any of other BMS systems, not just Niagara, any of the major BMS systems allow anything like that. If you know about that, please let me know. And yeah, it could give pretty different level of visual representation for your end user.